Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is indeterminate structures. So, in indeterminate structures, what kind of various structures are involved, how we are understanding those structures, and once understand the structures, how we are analyzing. So, we will see all these kind of things in this particular lecture. This is the indeterminate structural analysis as a part of module 2. So in this, determination of static and kinematic indeterminates and also analysis of stresses up to 2 degrees of internal and external indeterminates is using the Castiglione's theorem. So this is the module 2 we are going to discuss. So before going to this module, we have to understand what kind of structures are involved, what type of structures we are going to deal in our structural analysis. We will see all the things in this particular lecture. In previous lectures, that's module 1 belongs to arches. So we understand what are the various terms. We will see. We consider all those things. Now in this, we are understanding the structural analysis in various structural point of view. And those structurals, how we are categorized based on their determinate and indeterminacy. So what is meant by determinacy and what is meant by indeterminacy? So depends upon the structure type, whether it is beam, truss, whatever it may be, frames, whatever it may be, based on their supports, we have and different types of supports: roller support, hinge supports, fixed with movements, like this settlements. So all these various things are involved for identifying the structure. So once we are fixed with these supports, what kind of support it is, whether it is a roller, whether it is hinge, whether it is fixed one, and what kind of loading conditions are there. So we understand all these parameters. So once we understand what are the unknowns are there, according to the static equilibrium conditions, we know the static equilibrium conditions are 3. So in this static equilibrium conditions obeys, such type is determinate structures. So we are analyzing for those conditions. So these static equilibrium equations are not enough to analyze. Such type of structures are known as indeterminate structures. So we will see in these indeterminate, again we are categorized static, kinematic, like that, and also the various degrees are involved in this based on the degrees of freedom, and also the indeterminacy we have to understand. In this particular module, analysis of stresses with up to 2 degrees of internal and external indeterminacies using Castiglione's theorem. So now what we have to understand first, these analysis of indeterminate structures are involves methods for determining internal forces, what kind of forces we are getting. It depends upon the supports, what type of support it is there, and what kind of loading conditions is there. So loading conditions may be point load, concentrated loads, uniformly distributed load, uniformly varying loads. Like this, various different types are there. So in this, the indeterminate structures involves methods for these determining internal forces and also the displacement. So depends upon the what kind of support it is there. So in that, when the structure has more unknowns than the static equilibrium equations, so that is nothing but these indeterminate structures. We are analyzing those kind of analysis in this particular module. So the situation is known as Statical indeterminacy, it's a common in complex engineering structures like continuous beams, rigid frames, and some of the trusses also. We are going to understand the static indeterminacy. In structural analysis of indeterminate structures employs several specialized techniques that rely on compactability conditions. So because of these indeterminate nature, we have to understand the various methods for getting the unknowns, for know about the unknowns. So here these structural analysis for indeterminate structures employs several specialized techniques that rely on the compactability conditions. These deformation relations and energy methods, we are using various things. So in this we have some key concepts in indeterminate structural analysis. So in this static and kinematic indeterminacy, the static indeterminacy is nothing but the degree of redundancy. So the degree of redundancy, it refers the extra unknown reactions. So based on the type of this support, whether it is fixed, hinged, roller support, we are going to understand these extra unknown reactions are internal forces that cannot be solved by these equilibrium equations alone. So it is calculated based on the excess of these equilibrium equations needed for stability. So such refer is nothing but the static indeterminacy or degree of redundancy. In kinematic indeterminacy, this is nothing but the degree of freedom. So the static indeterminacy is nothing but the degree of redundancy. The kinematic indeterminacy is nothing but the degree of freedom. So this represents the number of independent displacement components. So in this kinematic equation, we are talking about the independent displacement. So here the internal forces, those are extra internal forces that cannot be solved by the equilibrium equations. In this kinematic, the displacement, we are going to understand the number of independent displacement components, those are translations, rotations, need to be described the structure's deformation. So we are talking about those structural deformation based on these displacement, such is known as the degree of freedom. In kinematic, that is nothing but the kinematic indeterminacy. And this method of analysis, there are several methods commonly used to analyze these indeterminate structures. Force method, displacement method, and energy methods. So in this force method, method of consistent deformations, force methods is nothing but the method of consistent deformations. Here in this particular method, assumes unknown forces or moments in redundant members and applies compactability conditions to solve for these unknowns. Move on to the displacement method. So the displacement method comes under displacement method under slope deflection is also comes under displacement method, and also the moment distribution method. These are the two methods which we are going to understand in this displacement method consideration. So focus on computing displacements and also the rotations directly. So these kind of displacement methods are typically suitable for beams and frames for analyzing the various indeterminate structures. So whenever the indeterminate structures, it may be beam or frames, we are going to consider these displacement method, one of the displacement method, whether it's slope deflection method and moment distribution method. Now coming to these energy methods, Castagnolin's theorem. So based on the energy principles such as the work energy method, this method is efficient for finding the displacements in structures by calculating the strain energy. So force method and displacement method, energy methods are the methods for analyzing the structures. So using these Castigliano's theorem, so the Castigliano's first theorem and second theorem, two different in energy methods. In energy method, the Castigliano's theorem is we consider. Here we have two different theorems in this. The first theorem, Castigliano's first theorem, state that particle derivative of the total strain energy with respect to an applied load gives the displacement at the point of application in the direction of the load. So, whenever the applied load and that gives the displacements at the whenever the point of application we are going to understand in the direction of the load. In this Castigliano's second theorem, it is useful for solving indeterminate structures. It states that partial derivative of the strain energy with respect to the reaction force or moment yield the displacement at that point. So, whenever the reaction force, displacement at that point, in first theorem, point of application in the direction of the load. So, these are the statements which we are understanding from this Castigliano's theorem. So, this is the formula which we are going to understand. Here, the Fi is the internal force. This is the strain energy formula which we used with respect to the redundant forces. So, F is the internal force member. F is the internal force member and L, I is its length, and once E is the modulus of velocity of the structure, whether it is beam, frame, whatever it may be. So we are considering this modulus of velocity. A is nothing but the area of cross-sectional area. So these are the parameters which we are going to understand. And differentiating this U with respect to the redundant forces, we obtain the compactability equations. So this is the formula where F is the internal force, L is the length, and E is the modulus of velocity cross-sectional area. So in this, for application in stresses, for stresses, analysis can be applied to determine forces in members of indeterminate stress, and also assume redundancies in specific members, and also apply equilibrium equation, considering compactability of deformation, and use Castigliano's theorem to solve for unknown forces, allowing structural safety assessment for various loads. So these are the various considerations, various concepts which we are going to understand in this module 3, that is analysis of indeterminate structures. So now how we are analyze what are the various steps involved in structural analysis for indeterminate structures. So the first one is determine the degree of indeterminacy and identify the redundant force, and also the set up the compactability equation, because indeterminates means we need extra equations for identifying the unknowns, and apply the method of analysis, which method is suitable for the condition, and analyze and interpret the results. These are the steps involved in the structural analysis for indeterminate structures. So here the determine degree of indeterminacy, first we have to understand the indeterminacy level, select the approximate method. So we have different formulas for how much degree of indeterminacy it is there based on the type. So whether it is static equilibrium or kinematic indeterminacy, based on the whether it is beam, frame, stress, and also the supports. These are all the parameters for identifying the degree of indeterminacy. So first we have to establish the level of indeterminacy to select the appropriate method. So once we identify these redundant forces, choose reactions or member forces are redundant based on the structural configuration. And once we understand the how much degree of indeterminacy it is and we are identify the redundant forces, now we are move on to the compactability equations and also use the relationship between the forces and their deformation to establish the equations for know about the unknowns, for getting the unknowns. Now choose the method. So it depends upon the type of indeterminacy and also what kind of structure it is, whether it is truss, beam, frame, and also they depend upon the type of the support, what kind of loading condition. These are all the parameters for choosing the method. So whether it is force method, displacement method, energy method, it depends. So each method has their own kind of calculations for identify the unknowns. So here first we have to understand what kind of degree of indeterminacy, identify the redundant forces, and we are set up these compactability equation using the relationship between the forces and the deformations. And now move on to the method of analysis. Once we identify the what kind of method, again these force and energy methods are subcategorized. So according to that, we are going to choose the method of analysis, what kind of procedure we have to follow. Once we identify the method, again they have involved few more steps. How we are going to follow the method and we are going to find out the fixed end movements and various determinacies. They are involved. It depends upon the each method has their own kind of procedure. So we are going to follow. First we choose the method. After that we are follow the procedure. Now we are analyze and interpret these results. So after obtaining the member forces and also those displacement, we are going to verify the structure performance against design requirements. So these are the various steps involved for analyzing the indeterminate structure. So in this, what structure analysis of indeterminate structures. So these structures are considered indeterminate when the static equilibrium equations are insufficient. These static equilibrium equations are insufficient for determining the all internal forces and reactions. Statically indeterminate structures provide greater stability and strength, but it requires more complex analysis techniques. So the degree of indeterminacy, whether it is external indeterminacy, internal indeterminacy. When the number of unknown external reactions exceed the number of equilibrium equations, such is known as the external indeterminacy. Internal indeterminacy, when the internal forces are more than what can be determined from the equilibrium equations alone, that is known as the internal indeterminacy. So here methods, what we understand. So force method, those are flexible methods. So method of consistent deformations, three moment equation, column analogy method. So in this method of consistent deformation involves compactability equations for solve unknowns. In three moment equations used for continuous beams. This kind of method, force method we are used, that is continuous beam. So this force method is nothing but the flexibility method also. This column analogy method applies to frames and is particularly useful for structure with multiple degree of indeterminacy is there. We are choose these column analogy force method for identifying the unknowns in this particular, for understanding the analysis. In displacement method, that is nothing but the stiffness method, slope deflection method and moment distribution methods are there. So uses rotations and displacements at the joints. And this moment distribution method distributes the moment at the joint iteratively. We will discuss it later. Now, in this, for force method, example of using consistent deformation, a proper cantilever beam of span 6 meters and uniformly loaded with W 10 kilonewton per meter. So first we are going to find out the fixed end moments. So the fixed end moment at A is equal to minus WL square by 12. That gives the minus 30 kilonewton meter. So like this, first step we are finding the fixed end moments, apply the compactability equations, define the reactions and compactability at the support, and calculate the additional reactions due to the redundant forces and solve the equations to find out the unknown. This is the general procedure which we follow for this consistent deformation. In displacement method, once we are using the slope deflection method, so a continuous beam with span of A, B, C. So this AB, this BC is more. So continuous beam ABC. So the distance between AB is equal to 4, BC is equal to 6 meters with a point load of 200 kilonewton at center of the span B. From here, that is equal to 20 kilonewton. From here to here, this is equal to 2 meters and 2 meters. From here to this, 8 meters. So like this, we are understanding the given problem. So continuous beam with write the slope deflection equations of each span. So that MAB is equal to EI by LAB. So 2 theta A plus theta B minus 3 delta AB. Similarly for BA. So we are going to write this modular of velocity and the length, all these things we are going to consider. This is the step. First write up the slope deflection equations of each span, apply equilibrium conditions at joints, solve the equations, find the rotations and displacements. These are the steps involved like this. Each has their own kind of different environment for understanding. Each method has their different steps involved for getting the unknowns. So here we are used these application in the design of complex structural systems such as buildings, bridges and frames. Provide a more accurate and realistic assessment of the structural behavior. Coming to these advantages, allow for the design more robust and efficient structures, provides insights to the distribution of forces and movements. Here also we are facing some of the challenges, more complex and computationally intensive than determinate analysis. Requires good understanding both structural and mathematical techniques. So these are the overall overview about the analysis of indeterminate structures. How we are going to understand based on the various methods involved, force method, displacement method and energy methods. Again, they are categorized. Some of them are suitable for some of the structural elements. So we will see in detail about in further classes, next classes. So these are the some of the references helpful for understanding the what is meant by indeterminate structures, how it is helpful. So these are the things we will see. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.